Hello, and welcome to the Intercloud Computing, how TOSCA helps open telecom cloud users run anywhere. A couple quick notes before we get started. This webinar is being recorded and live streamed. If you would like to submit a question, we will hold those until the end, and please submit them in the Q&A box that's at the bottom of your screen here. Today we have two presenters. The first is Alexander Navratil, the chapter lead architect for Open Telecom Cloud, and Trevo, who is a cloud architect. And with that, Alexander, will you please take us away?
Hello, everybody. Thanks for the warm welcome. Am I audible?
Yes, we hear you.
Thank you. Yeah, it's a pleasure for me to be here and have today the opportunity to show you a little bit of our capabilities in our cloud environment. A little bit of me. So my name is Alexander Navratil, as already mentioned. I'm the chief architect of Open Telecom Cloud. As well, I'm the chapter lead. So you read here chapter lead. It's a little bit different than a department lead because we are organizing ourselves in an agile way or an agile transformation structure. We are coupled to the Spotify organization model, which means we are working in a tribe structure, which is divided into several squads and as well in several chapters as a horizontal functionality for architects, engineering, and operation excellence, as well in the operation side. Going away a little bit from the Open Telecom Cloud, who we are, what can we do with Open Telecom Cloud, or how does Open Telecom Cloud look like? So Open Telecom Cloud is a little bit more than a standard cloud, as you know, that in a private manner. So this is not only a couple of racks which you can use for dedicated purposes. So Open Telecom Cloud is a public cloud like all the other hyperscalers which you know on the market. So in that respect, we see here us as the biggest OpenStack platform in Europe. So what does it mean, biggest platform? In our perspective, we are occupying now more than 6,000 square meters in data center structures. We are segregated by different data centers in different locations across Europe. So that means in Germany and in the Netherlands. In these data centers, you can see there are more than 90,000 assets. Yeah, distributed to compute, storage, network, and so on. These are Open Telecom Cloud, but not only these is Open Telecom Cloud. Open Telecom Cloud makes us so special because we offer a huge bunch of service delivery, which is combined under the asset umbrella, like infrastructure as a service, as well the platform as a service, and in addition, for sure, the software as a service part, which you can find there. As I mentioned, the infrastructure as a service we deliver in front of our customers since 2016, sorry. This means we start at the end of 2016 and deliver the first services in front of customers, which means it's all virtually servers reachable via the API infrastructure, which we provide towards the customers. In that stack, we also grow our environment to a really huge amount of storage, which we can deliver in front of the customer. More than 450 petabytes of storage are still available in our environment. And why I mentioned that here, this is so funny if you come to a level where you think, what can you do with such amount of storage? Could you imagine the IIS in the orbit has a distance for more than 408 kilometers? Yeah, you can build up a pile of CDs 3 times at the distance if you want to have the same amount of storage in respect to 450 petabytes. This means also 38,000 years of rock music if you want to use this amount of storage. This is really huge, guys. So I'm definitely sure we can fulfill the purposes of storing data in our environment. What you can see here in the background, this is a huge building there. This is one of our cluster buildings where we deliver our Open Telecom Cloud from. This is in the near of Magdeburg, as here an example. What are the difference, or what are the differentiators if it comes to the case? Okay, you mentioned, Alex, this is like the other hyperscalers. What makes you special? We are in that case a little bit special because we are completely compliant with the general data protection regulation, what that means in the GDPR. This is not a question why, this is more than a question how we do so. Because we are delivering our service with the full operational on European level, which means all our cloud admins, engineers, architects, operators are based in Europe. So this ensures we are here delivering our service under the regulation of the GDPR. This is not only the thing what we can offer in Germany, so we can deliver to the world out of that environment. As well, we can deliver in front of the customers a lot of certifications if it comes to security question. We are under the regulation of the BSI C5 audit. We can deliver that in compliance to SOC C2, as well to the ISO certification 2718, and all these which is related to cloud and cloud cybersecurity. This is fulfilled by ourselves. You can read that by yourself if you want to have a look on our official page. It's Open Telecom Cloud. You can see that there in the first chapter of information, how many and which certificate we can here offer in front of the customer. How we use TOSCA, or why we use TOSCA. TOSCA is for us the first thing which comes to our mind if we talk of intercloud computing. You can make use of Open Telecom Cloud in a hybrid phase as well in the public phase to ensure you can transfer your data from one island to the another island without any redeployment efforts, only by clicking a simple button. This needs the interconnection and the intercloud computing regularities, which is done by the Technology Forum in 2011. We are stick to these plans, and 3, which is then described that in detail how this is working, we are working really heavily then to make that happen for all of our service, which we try to offer with these cloud services. So what does it mean in total? Let me choose one use case, yeah, why this is so important to be here, multiple deployable. I try to get a little bit grip on it if it comes to avoid a disaster recovery scenario. Most of the times, if you talk by a disaster recovery scenario in a cloud environment, how secure and how reliable is the environment by himself? Did you ever consider a virtual disaster scenario? What does it mean, a virtual disaster scenario? Let us think a little bit further. You plan to roll out your application environment towards one cloud provider. Doesn't matter to which one. Then you indicate how many compute powering you need, how many storage you need, which kind of network you need for that, and which service you can combine there together, and all these stuff. Then you place everything in a deployment, and then you roll it out to this cloud provider to ensure nothing will happen because you're responsible for the cloud application by yourself. Then you ensure that by clicking the button for dumping data, storing data, backup data, use disaster recovery scenarios for these cloud providers. This will ensure if something happens on that layer, a data center will be turned off, a breach of network or something like that will happen. This ensures your service will be available. But what happens if someone in the cloud provider uses the wrong button and kill your whole tenant or kill your whole environment in contract phase, which means something went wrong on the billing chain? Then your completely tenant is gone. What can you do to avoid this scenario like that, which I call virtual disaster, then you can deploy your environment not only to one cloud provider, no, you can deploy it to several cloud providers. And to do so, everyone who tries to do that by themselves knows how many effort you have to spend for it, because you have to fulfill that with different cloud provider identities. Then you have to make sure the login is the same. Then you have to make sure the interconnection works well. Then you have to do the adjustments on the deployment level, and so on, so on, so on. You need different providers. This is such a painful scenario, which then you're in front of, because it creates huge efforts. This is one of the major reasons why I see this is so utmost important for everyone who comes into this virtual disaster recovery to make use of TOSCA. And this is one of the reasons why we want to offer that to our customers, to be aware and have the possibilities with only by hitting one button and select the different cloud provider, and maybe deploy that there as a standby, as a hard standby, or maybe store only the data there to ensure no data loss will be happen, or something like that. This should ensure for every and each customer which is on our platform, a virtual disaster which can happen, which we see in the historic, which we see in the past, will not hit customers such hard as without any cloud or multiple cloud usage scenarios. This is nearly the end of my part of this presentation, and I would like to do the handover to Tree, which is one of my colleagues in my department, and I guess he will start with a short presentation, with a little bit of an introduction and a short presentation, how our TOSCA topology designer look like. And if this is okay for you, Tree, then I will stop here my presentation and I will do the handover for you.
Please. So my name is Sri, and I will continue the second part of the presentations. Our customer often come to us and ask the questions why we use TOSCA, what is special about it. So to answer this question, we want to compare it with the most frequently used approach that we have nowadays, for example, Terraform. So in general, we can see the Terraform as a bottom-up approach. What does this mean? Briefly, it means that it's a hard coding implementation for a specific cloud provider. It's hard coding in terms of image flavor, especially network, subnet, security group, and so on. And when you hard coding it, it's only work for a specific cloud provider. So if your cloud workloads, work application and workloads live happily forever and ever until the end of its life on just one cloud provider, and this is totally okay. But it has a limitation. If your cloud workloads have to change the infrastructure frequently, or have to update the topology frequently, then in this case you have some limitation. TOSCA, on the other hand, is a bottom-up approach. We consider it as an application-centric approach. Why? Because the user focus on describe what the application needs, which means full presentation of the application layer and the infrastructure layers. And afterwards, infrastructure has to serve the purpose of the application, serve the reasoning of the application, but not the other ways around. If you don't know about TOSCA yet, we will give an example about it. So you will see there's a demo, there's a transformation, but at the moment, if you don't know about TOSCA yet, just remember that first of all, the user describes the application topology, and afterwards, there will be a transformation happens at runtime. So now we'll give you a demo. At Open Telecom Cloud, we offer our user the Cloud Topology Designer, design once, run anywhere. So like the name says, our user use it to design the application, and afterwards they click on one click, they can deploy it on Open Telecom Cloud. They click on another click, and we will deploy the application on Google Cloud. We will give you a simple example in the demo. And after the demo, we will come back here and we'll talk about the open source projects that we use behind. So now I will continue with the demo. So first of all, our customer will log into, we use their credential, which is an OpenStack credential, to log into the Cloud Topology Designer, and afterwards they can start to design the application. So as I said before, here the user has the possibility to design the infrastructure together with the application layer. So in this example, we will have a simple application which have one compute node. The compute node has one CPU and RAM. And then the user can also design the network. And here in our example, the compute node is in one private network, and the compute node is also has access to the internet, which is a public network. So this is the description of the infrastructure. As I said before, the user also has a possibility to describe the application layer on top of it. I already write a simple script, which is basically just install Nginx, and then it will bring out hello world on Nginx. So a very simple application. To control the lifecycle of our script, we develop a pass component, which is a generic software component of TOSCA, so that our user can control the lifecycle of a pass component on top of the compute node. Here I select the pass component, and I can choose the script that I wrote previously to install Nginx. So basically, this pass component will install Nginx or the compute node when the compute node is up and running. Because Nginx is running by default on port 80. So now I have the possibility to also specify port 80 as a requirement for my application. What does this mean? It means that because this Nginx is up and running with connecting to the internet, so at runtime, a security group will also auto-generate it to allow the traffic from the public internet to my application. So now I can save my my design, and now I will start to deploy my application. So in the demo, I will first deploy it on Open Telecom Cloud. So to deploy it on Open, here the user can choose where they want to deploy the application. So in the first deployment, I will choose to deploy it on Open Telecom Cloud. So I just click on that. And here at runtime, it will show me on the matching flavor that is available on Open Telecom Cloud. So this flavor is very specific to Open Telecom Cloud, so that I can choose it, and then I can deploy it. So it's just one click away. So what does this mean? This means that so here I will show you that during the deployment, this is the topology, the transformation that happens only for OpenStack, for Open Telecom Cloud. Here we see that, so we remember that, recall that in OpenStack, we have the presentation of the network port, neutral network port, and so here we see that the security group is automatically generated so that it can allow the incoming traffic on port 80 for me. And because in OpenStack, the security group is associated with the neutron port. So here we can see that the topology is the topology is transformed automatically to serve the purpose of the application. So here you can see that there's a transformation that is only work for Open Telekom Cloud. When we give in the demo, when we go to the deployment of Google Cloud, then you will see the topology transformation is different for Google Cloud. If we go to this is the cloud console of Open Telekom Cloud, and maybe I will come back later because it's still in deployment. So here you can see that the virtual machine is up and running with the right flavor that is only for available specific for Open Telecom Cloud, and you can also see that the security group is automatically created and associated with the neutron port of the virtual machine. So now I will deploy the same application, but on Google Cloud. So here I already have the same application, and I will deploy it on Google Cloud. The first time I deploy it on Google Cloud, it will redirect me to Google Cloud so that I can authenticate to Google Cloud, and then I can give the permissions that the cloud topology designer to have the permission to work on behalf of me and manage the resource on Google Cloud for me. In terms of identity management, it means that the user identity of Open Telekom Cloud is now federated with the user identity of Google Cloud. So now I have here it will list a list of projects that I have the permission to deploy my application on Google Cloud. The user also have the possibility to review the transformation. Here, for example, he can choose the availability zones for their application. Sorry, for their virtual machine. And here you can also see that they have the possibility to reuse the key pair. This is a key pair that is managed by managed by the Open Telekom Cloud, and the user has the possibility to reuse the key pair here on Google Cloud as well. So by doing this, we will reduce the complexity of key management for our customers. So they just need to have one place to manage their SSI key, and they can use the SSI key on the other cloud provider. And now they can just one click away to deploy it on Google Cloud. Sorry, I don't know why we have key pair. The key pair is right. So it's so now you can see that it started deployment. Let's wait a little bit. You can see that the topology is now different because in Google Cloud, we don't have a neutral network, and we don't have a network port, but the compute node is associated with the network, the subnet directly. Also, we see that in Google Cloud, the Google firewalls does not associate with the neutral network port, but the firewalls is created in the VBC network nodes. So here to say that we can see that the topology is transformed from the original topology to the topology that is only specific for Google Cloud. And all of these transformations is transparent from the user, from the application point of view, because as I said before, the application has the user can focus on this on developing their application, and later on the infrastructure has to automatically adapt it and transform to serve the purpose of the application, but not the other way around. So this is only a simple example for that. And we can have a more, also have a more complex scenario. For example, here in this case, we can have multiple network on the back end, and we can also have this one. So at Open Telecom Cloud, our customers say that we don't want to learn TOSCA. We how to do that. So we develop a very generic software component, which so that they can control Ansible, they can control the lifecycle of Ansible and the pass component here. Why this is generic? Because our users simply input the environment for the application, and this environment is automatically available as a TOSCA input inside the Ansible script, so that they don't need to modeling the software component by themselves. Also, when they can also connect the pass component to the Ansible component, and by doing this way, the environment variable of the Ansible component also automatically available inside the PassScript component, so that the PassScript component can use it to establish the connection relationship with the target component. So this is also another improvement from our side, so that our customer, they don't need to work on modeling TOSCA by themselves. So with that, I will go back to the presentation. Let me check the time. Yes, okay. The open source projects that we use is the Alien for Clouds and York from Atos. If you are interested in TOSCA, so please contribute to these open source projects and make it more successful. From our point of view, this is they have very good, they have a decent architecture to start on, and to work on. From our side, we enhance these projects with security, with identity management, and with some feature that is work for Open Telecom Cloud, for example, for security, because we have multiple users from multiple tenants that use the cloud topology designer. So we have to make sure that the resource is isolated with each other, and to protect the user privacy in a way that all data is encrypted and can only be decrypted in a way that is decrypted in for a specific purpose and in a given time, but nothing more. For identity management, we enhance it with single sign-on with OpenStack key store and Google authentication and authorizations. And for the future, we improve it with additional transformation for security group for multiple networks, and also for feature like SSH person host. So in summary, if you can follow the demos and follow the presentation, it's good. If you don't, then we summarize it in, there are 3 takeaway for you to take away. So the first takeaway, the first tag is that TOSCA describe a full presentation of the application topology. And after we have the full presentation of the application, the transformation can happen on the infrastructure, like as we see in the demo. We see the transformation happens on the infrastructure, but not limited to the infrastructure, but also on the application layer as well. For example, an application component is replaced by a software as a service at runtime. So this is also possible. For this, we consider the TOSCA approach is the next generation of cloud adaptations. Why? Because the cloud adaptation does not happen only at the development time, but also happens at runtime. And the transformation here depends on the information that is available at runtime, but also the transformation also compliance with the user requirement, what the user specify at the design time. So think about it, it's very powerful in this way, and it's open many doors, many opportunity to have a workload that is self-description or self-transformation. So this is also possible. Limitation. We think it has some limitation as follow. At the moment, the orchestration engines must contain all the built-in knowledge about the specific cloud provider. There's no magics behind TOSCA. It has to rely on the reasoning engines to do the transformation. For example, transformation from TOSCA network to Google VPC network and subnet and so on. So that's why the orchestration engines has to contain a lot of built-in knowledge. And the orchestration engines out there, they may implement it repeatedly, or they may implement it differently. This is the second tag. So we come to the third tag is that the third takeaway is that there's room for improvement, and we think if we can separate the transformation knowledge, the built-in knowledge outside of the orchestration engines in the way if TOSCA TC can provide a meta model so in a way that the TOSCA community can use this model, meta model, to describe the transformation. In this way, we can separate the built-in knowledge from outside of the orchestration engines, and so that the transformation can be more easily and flexibility. This is followed by the model-driven architecture. And with this, we want to complete our presentation. And as I promised to Chris, we have 10 minutes for question and answer. And yeah, I think we have exactly the time.
Perfect. That was great. Thank you so much, Alexander and Tree. That was the power of TOSCA. So just a couple questions, and then I'm going to turn it over to Chris, who's going to give you some general information about what's happening and what's coming for the TOSCA Technical Committee. So we have a question here again. Please feel free to post your questions in the little Q&A box. Here's the first one. Can we choose more than one deployment locations to be used simultaneously?
Yes, as we saw in the demo, we can choose the location differently. Okay,
great. So here's some other questions that I just received. I think I have someone raising their hand. Jane, I'm not sure how that works here. Just hang on one second. Let me see what I can do. I do have a raised hand.
I can allow them to speak.
Okay, awesome. Go ahead, please.
Okay.
Mustafa, sir? No, I don't hear anything.
Yeah, there's one more.
Okay.
Let me
allow them to speak. Okay,
allow Adam to speak.
Hey, Adam, what's your question?
Can you hear me?
We can.
Yes.
Great, okay. So my question is, which orchestration engines are compatible with TOSCA?
So the orchestration engines that we use in our projects that is come from Atos. This is Alien for Clouds and York from Atos that we use, and this is compatible with TOSCA.
And are there any other orchestration engines, or are these the only two at the moment from Atos?
There are many more compatible orchestration engines for TOSCA, and Chris has a list of them. I don't have it in my mind at the moment. I'm sorry. I think if you can contact me later, and I can send the list to you.
Oh, that would be great. Yes.
Chris, you want to help out here?
Yes, Adam. This is Chris Lowers. I'm the chair of the TOSCA TC. We have a website at oasis-open.org, and that is the website for the entire OASIS organization, but there is a subsection that's dedicated to TOSCA. On that TOSCA subsection, we have links to a wiki that contains a list of known TOSCA implementations, and the York orchestrator is one that is referenced, but there's about, I don't know, 30, 40 or so other ones that you can look up, and these are full-fledged orchestrators. There's tooling for design, there is parsers, validators. There's a whole variety of tools that you can look at that can help you get started with TOSCA. We'll send out those links after the presentation when we send out a link to the recording as well as to the slides, so you'll have that information available.
Terrific, thanks, Chris. Mustafazur, were you able to come on?
Yes, can you hear me?
Awesome. Yes, perfect.
Yeah. So, as per my understanding, first of all, I am a very beginner in the OpenStack. So, I would like to know, as per my understanding, the language is using TOSCA is YAML file. So, is there any other language which is using in TOSCA file or any other things?
We use the simple profiles of TOSCA 1.3 is in YAML format.
Any other format or only YAML is the accepted
We
format?
only use YAML format.
Okay, okay, thank you.
Anything to add to that, Chris?
Yes, maybe to explain the decision to use YAML. TOSCA is intended to be used by end users, which means that the language in which the service templates are encoded has to be extremely user-friendly, and YAML is the best option for that. The early versions of TOSCA actually used XML, but as you know, XML is much more suitable for use by computers than by humans. So about 5 or 6 years ago or so, the TOSCA technical committee decided to switch from XML to YAML, and that has significantly improved how easy it is to create TOSCA service definitions using the TOSCA language. We did do a webinar, by the way, probably about 6 months ago, that recaps some of the history of TOSCA and highlights the specific advantages of TOSCA compared to other orchestration technologies. And again, we'll send out links to those to that webinar as well. So if you wanted to review and get up to speed on the history of TOSCA, you'll have an opportunity to do that by watching that webinar.
Very good, thank you. We've got some clarification on the first question. Can we choose more than one deployment location to be used simultaneously, not in different deployments in the same, in the same deployment? I'm not sure, does that provide any more clarity?
I guess this goes into the direction. I guess this goes into direction if this is possible to deploy with one deployment template into multiple environments. Yes, this is possible.
Great. So the answer.
That's my interpretation from this question.
Yeah, and can you do it at the same time? Can you have multiple deployments go on in parallel? I believe was that the question the audience had.
Yes, and this is the purpose of automation, right?
Okay, great. So I appreciate everyone staying with us. These questions are fantastic. Can you talk a minute about the support Kubernetes workloads in public clouds via the designer capital D?
We plan to support Kubernetes and because we see As I pointed out before, we pointed out before, we see there are this is a next generation for cloud applications, in particularly in microservices, in edge computing, and in IoT, whereby the microservices will can migrate from A to B to C to D very frequently. So, and when this is migrate from A to B and B does not exist before, B has to be automatically created with on the link. So in microservices, normally we have a complexity of connection relationship between the microservices itself with other. So when this is migrated to a new environment, it has to maintain the existing connection relationship with the all microservices in the own environments. And this is only possible with TOSCA because where you have a description of relationship between the component, and when you have a full description of relationship of the component, then the transformation afterwards is possible. So this is why we also choose TOSCA, and at the moment we still don't support Kubernetes yet, but this is also in the roadmap to support Kubernetes in the future. Yes.
Terrific. Okay, so I'm going to wrap with this one because I want to leave a couple minutes for Chris. So the last question is, which version of TOSCA is supported? And this is probably a Chris question. Oh, I guess I'm sorry. They're probably asking that of you, Tree, and or Alexander.
What was the question again? I'm sorry.
Which version of TOSCA are you supporting?
We support 1.3, the latest version.
Okay. Terrific. Very good. This has been fantastic. Chris, could you just take a few minutes then and bring us home?
And actually, before I do that, Tree and Alexander, I have a question of my own. You mentioned that one of the limitations you had to deal with is related to the transformation of the high-level abstract service template, if you will, into cloud-specific templates, and that you need knowledge built into the orchestrator about the specific cloud platforms to perform that transformation. Now, TOSCA has a feature called Substitution Mapping, where you can define in an abstract service template, you can define abstract nodes of specific types that then get substituted with entire topology templates, where those topology templates that substitute the abstract nodes can be specific for each platform. Have you investigated the use of substitution mapping at all to make the transformation more general purpose and eliminate the need for the orchestrator to have built-in knowledge about the transformation?
Yes, when you take a look in the substitution in the current specification, then you can see it's still somehow limited. And if you use the derived form and abstract, this is I think this is not yet to the level where we can define the transformation into the element details of the properties. Folks, I still not yet have the full power for define the transformation with the current substitution element. For example, the TOSCA has one network element, but in Google Cloud we have Google Cloud VPC network, we have subnet, we have, and each of these elements also have the properties. So the question is that how this property can map with each other and so on, and it is still not is possible to define the mapping. So if we take a look in the other TOSCA OASIS standard like BPMN or PEOPLE, business execution language, then we can also see there is a mapping between the element, but in the details level, so that the transformation between one service provider to the other service provider is possible. That transformation in details.
Okay, that's actually very helpful, and that leads to maybe the final set of comments I wanted to make. I think this is exactly the type of real-world experience that we are looking for in the TOSCA TC to help make the standard even better, and to sort of fill any gaps or any holes that people may have when they try to use TOSCA for their specific application domains. We are currently working on TOSCA version 2.0, which is intended to support a much broader set of application domains than the original 1.x family of standards currently supports, and is intended to be much more flexible from a functionality point of view. So we would very much welcome people's participation in the standard and bring these experiences and these limitations as you see them, so that we can jointly as a team work on addressing those limitations. If you're interested in participating, the OASIS website, where you can find information about TOSCA, again, we'll send that out as part of the information about the webinar after today. But the URL is www.oasis-open.org. So that's your starting point for contacting us about information about TOSCA. We will continue these webinars every last Wednesday of the month. So the next one will be held on March 31st, I believe it is. And then we'll go to the last Wednesday of April, last Wednesday of May, and so on. This is actually the second webinar in this series. The first one was done at the end of January by Tal Liron of Red Hat, where Tal went into detail about how to use TOSCA orchestration for Kubernetes as a as an alternative to Helm charts, and arguably a superior alternative to Helm charts. So the website about the implementation series has a link to the recording of that webinar as well, and I invite you to go check that out if you were unable to make that presentation. So again, we would welcome anybody's participation in the TOSCA TC. Please reach out through the website, reach out to myself or Dee and Jane, and we look forward to having you participate and make TOSCA an even bigger success than it already is. So Dee and Jane, I think that's all I wanted to say. Look forward to having everybody. I look forward to having everybody participate on March 31st as well.
That's fantastic, and I will send the link to the next. I'll send an invitation to everybody for the very next session. And thank you, Alexander and Tree. That was fantastic. We appreciate it. Everyone have a wonderful afternoon or evening. Thank you.
Thank you. Bye-bye.
Thank you very much for the opportunity. Have a good one.
You too.
Bye-bye.